Hello. Because this is a tough section, I decided to make a second video on forces in one dimension. So, we're going to go through a couple more examples, and hopefully it'll get better. So, first example. You attach a 2 kilogram weight to a spring scale. You lift the scale and weight with a constant reading of 22.5 newtons. Or A, what is the value and direction of the acceleration on the weight? Alright, so we're only looking at the acceleration of the weight. So we're looking at this thing from this point here, center of mass of the weight. Now, we need to calculate the net force. So, F net equals. Let's look at the forces being acted on this weight. So, the most obvious one is the force of gravity, Fg, which is just the mass times gravity. And that's pulling down on it in a negative way. And then our second force is coming from the tension of this rope right here that's attached to the scale. And it did already tell us exactly what that was, the tension of that rope. So this is the force of tension, which is 22.5 newtons. So our net force acting on this thing is positive 22.5 minus this mg here. So we have force of the tension minus force of gravity equals 22.5 newtons minus our mass is 2.0 kg times negative 9.8 meters per second squared. So that gives us the total net force, which happens to be 2.9 newtons. Now it wants us to find the acceleration of the weight. Alright, so we know our acceleration, and we can make all of these vectors, because that's what they are. The acceleration is just the net force divided by the mass of the weight. So we have 2.9 divided by 2.9 newtons divided by 2.0 kilograms. Which is about 1.5 meters per second squared. And the second part, how far do you lift the weight in the first 2 seconds? Well, we have our acceleration. So we can use the standard acceleration formula. S equals 1/2 AT squared plus V naught T plus S naught. We're trying to find this. So we have S equals 1/2. We found A to be 1.5 meters per second squared, and time is 2 seconds squared. Our initial velocity is 0, because it says in the first 2 seconds. Our initial position is 0, so that's all we're dealing with. Those go away. So S equals 4 times 1.5 is 6, divided by 2 is about 3 meters. Okay, number 2. A jet flies at a constant altitude. Its engines produce a forward thrust of 8.4 times 10 to the 5th newtons. So, rough drawing of what's happening. We know the thrust is always in the direction that the plane is going. So let's say the plane is going to the right. And that's our force of thrust. Alright, and we know that's 8.4 times 10 to the 5th newtons. The mass of the jet is 2.6 times 10 to the 5th. We have that here. What is the forward acceleration of the jet? Alright. So, not too bad. We know the force of thrust equals mass times acceleration. Both of those have direction. We know our thrust is 8.4 times 10 to the 5th newtons equals the mass times acceleration. So 2.6 times 10 to the 5th kilograms times our acceleration. So you just divide by this number. So our acceleration is 8.4 times 10 to the 5th divided by 2.6 times 10 to the 5th. And this is going to be in meters per second squared. So our acceleration is 3.2 meters per second squared. Okay. How much upward force must the air exert on the jet when it is flying horizontally? Okay. So let's think about this. We know force pulling down on this thing is due to gravity. And we can figure that out. And the force we're trying to find is the force of lift. Right? That's what's keeping the plane up in the air. From Newton's third law, we know the force of gravity here is equal to negative force of lift, or vice versa. We know these are negative but opposite. So we could say what we're trying to find, our force of lift, equals negative the force of gravity and we also know our net force here equals 0. Because the plane's not going up or down. It's flying in a straight line. So these two forces have to cancel out, and therefore it's not ascending or descending. It's flying straight. So that's a big thing. Net force is 0. Now we plug in some numbers. So our force of lift equals negative, and lift is going to be positive in the end. We know this because it's upwards. mg, so equals negative, our mass is 2.6 times 10 to the 5th. Our gravity, negative 9.8, because it's acting in the opposite direction. So we use a negative, meters per second squared. Our force of lift is 2.5 times 10 to the 6th power newtons.